Thank you, Stephen. Hello everyone. I'm Shivani, and I'm here to present on the topic importance of explainable features for data science and business. I work at Scoutbee, and what we do, so we operate in supply chain industry with main focus on procurement and supplier information and intelligence space. The main goal of Scoutbee is to have a stable supply chain for companies, and to achieve this goal, one of the problem statement that me and my team is working on is that when a customer comes in with a demand, they would like to have a list of suppliers which are relevant to what demand they are looking for. I will elaborate more on the problem statement by giving an example. So let's say a customer comes and they say, hey, we need 100 round steel bar manufacturers, preferably in Europe and with some certificate. And then Scoutbee says, okay, we will provide you with a list of suppliers. So what makes Scoutbee different is that in traditional scouting, you first have like 10 suppliers, you screen them, and it is all a manual effort. And then 8 of them are validated. Then the 8 suppliers are collaborated. 4 of them are pre-selected, and then we onboard like 3 suppliers. And this whole process, it is not just less exploratory, but also it is more time consuming, and it took approximately 24 weeks. And when we introduced AI in Scoutbee, so we could explore and exploit both at the same time. And so 1,000 suppliers were screened, and out of them 100 suppliers were validated. Out of them 100 suppliers were collaborated, 20 suppliers selected, 10 suppliers onboarded. And so we also have a increased list of suitable suppliers, and it also took less time. So it took just 6 to 8 weeks. But I would like to say a point here that we don't really have a total removal of humans. So humans are also included in this process of, even though AI was introduced, so humans are still there in the loop. Um, I am working on developing a ranking model. So given a list of suppliers, the ranking model will rank the suppliers based on what the demand is required. And then we have domain experts who will go through each of the supplier and mark if it is relevant or irrelevant. And based on that, the ideal situation would be that the top 100 suppliers are found in the top itself by the ranking model, and then the sourcing operation, or then the domain experts don't have to go through each one, and they just get the top 100 suppliers in the top list, and we reduce the manual efforts. But I would say it is still ambitious, because here we are dealing with unstructured data in terms of websites. And so it's important that we ground ourselves and say, okay, let's not go to that extent that we want to eradicate humans in the loop completely, but we want to lower their efforts, manual efforts in the whole process. And also, if we remove domain experts completely, I don't think the customers would be happy with that and comfortable with that, because they also need to know that, okay, someone also validated the suppliers, and it was not just some AI-based model which gave in the results. And how is the ranking model trained? So going back to the previous slide, so the domain experts mark which supplier is relevant and not relevant. And this data is given to the ranking model for training. And when a new demand comes in, the ranking model, the trained ranking model, will then predict which supplier is relevant and which is not relevant for this particular demand. So when I first started working on this problem statement, the ranking model was super complex, and Stephen just said that bad data holds us back. And I would like to add that it's not just bad. I mean, if bad data holds data science back, bad features hold the model machine learning models back. And so I was like, okay, I am training the model, I'm trying different algorithms, but still we got stagnant results. And so then we as a team decided that let's just try a new approach, a simpler one. And before saying what the solution was, so I would like to divide explainable AI into two parts. One is where we provide the explanations after the ranking model gives, after a machine learning model gives the predictions, and then we have a explainable AI module which says why this particular supplier was ranked at this particular position. But when you give such explanations to domain experts, they are not necessarily data scientists, and they won't know what features were there. And even if you say give them some sharp plots or some heat maps and say, okay, these were the features that affected the performance of the model or that affected the prediction of the model, it is not necessarily understandable by them. And then when let's say the ranking model gives a prediction that it ranks a particular supplier at particular position, and then the domain experts are not happy with the results, and when they are not happy, they go back to the data science and say, hey, why is the model giving such bad results? Then the data science has to generate the sharp plots and so on, and then there is a loop which is, I think, a longer process. And to tackle that, what we did was we used the second solution, that we have the interpretable ranking model, which is self-explanatory in itself, which has self-explanatory features. So when we provide the predictions of the ranking model, we don't just provide the predictions, but we also give the features that were used, because we don't need to really have another set of explainable AI module. We just in a way give the features that the ranking model used, because the features in itself are self-explanatory. So now when the model is performing bad, the domain expert can also know which feature was causing the model to be bad, or why, which feature caused the model to predict a particular supplier's position. And so they can just say, hey, I don't think this particular feature is required from now on, and they can say we need to remove this feature. And so yeah, it basically solved it two problems. And yeah, so the main motive behind this solution was we want the machine learning models to be to mimic how we humans think. So we took the same approach. We saw, okay, the domain experts, how do they look for relevant suppliers? They see, okay, is this particular product given by the suppliers? Then they say that, okay, this supplier is relevant. And so we thought maybe we mimic this thing in some way, which was in terms of explainable features. And the overall impact that we achieved was we got a reliable and explainable ranking process, because then the domain experts knew exactly what was causing the particular results. And because they could see this particular feature is affecting this particular supplier, when they were putting in manual efforts, they could also in a way say, okay, I don't think this feature should be considered important, and they could in a way just skip the supplier, and this in a way reduced the overall long list generation time. There was also an improvement in relevancy rate, and when we saw that, I think we as data scientists, we tend to go with complex models and we think it is very fancy. But I think you should first, I mean, I learned the what I learned through this journey was you should always start with the simplest approach that is possible and then go to a complex model. um, yeah, because the results, because when the ranking model was providing the results, and even the data scientists were like confident that, okay, this is the reason why this particular supplier was ranked, we could also question the domain experts if they thought that a particular supplier was not relevant. And so this in a way also reduced the overall curation time in terms of model deployment, model building, and model updation. And yeah, so it was a win-win situation. And questions?